Okay, good afternoon, everyone. This is going to be a nice session, I can see, with half you lot over there and the other half there. And of course, I like the one sitting in the middle. So if anyone feels left out during the presentation, just raise your hand and say, me, 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 and I will address that side a little bit more. So, you know, that's the way of the game. All right, my name is An-Margritt Ryste. I work at Kongsberg Maritime, and I'm the program manager for autonomy development for maritime autonomous surface ships. And I'll go into details about what that means and what that is. And thank you so much for sitting in, listening to the final session of the day. I understand it's been a really interesting couple of days. And this topic is perhaps a little bit on the side of what you have been listening to the past couple of days. So thank you for coming here. During this session, I will focus on the motivations and the steps towards autonomous maritime autonomous surface ships, and why now is a good timing for starting to work with this, the key elements of mass, and then what? We have a vessel, we're going to develop a lot of technology for that, but then what? We'll get into that. But before I start with the details, I'd like to share with you Yara's motivation for going into the presentation and starting this really cool concept with the world's first fully autonomous, unmanned, zero-emission and ballast-free container vessel. So just watch this.
Earth. It's filled with incredible wonder and immense challenges. And it is our collective hunger for innovation, our curiosity, and our collaboration that grows our knowledge and allows us to thrive.
This is the first autonomous commercial vessel in the world, and it's also the first commercial zero ballast vessel in the world. The idea was actually to transfer the goods from the road into a conventional container feeder. That was the start. And then we started to look into more environmental friendly ways of doing the shipping activities.
Yara is a fertilizer company, not a shipbuilder. So to make something like this a reality, we had to collaborate. For us, the natural and very good partner was Kongsberg, who has the technology to pull something like this through.
This project is the world's first fully electric, autonomous, ballast-free container feeder. So it will be a game changer for the environment and for the shipping industry.
The number of containers coming out of Porsgrunn have risen steadily, and it's become more of a problem the last, say, 5 years. So over time, we have been more and more interested in solving it.
This vessel will transport fertilizer from Yara production plant to the two export container ports in Brevik and Larvik. We estimate that on behalf of Yara, it will transport approximately 25,000 containers per year.
They have a real need, and they need to improve the local environment where they operate. So that's what's so exciting about this project.
And I think what set this opportunity aside from many others is that we could reduce emissions by moving truck transport to sea. The thing about Yara is, if you look at our mission, is to feed the world and protect the planet. And very few opportunities arise that both enable us to save costs, to impact the environment in a good way, but also to really impact the wider business community positively.
Okay, so now you know a little bit more about Yara's motivation for going into this project, the world's first project. But as you have perhaps noticed, is that Yara is not a shipbuilding company, they are actually a fertilizer producer. Why are they coming to a technology company with a logistical problem? That's in essence what's going on right now. So we are really changing the game of the shipping industry just by this one actor being willing to take the risk to be the first. Okay, so that's Yara's motivation. What about Kongsberg's motivation for doing this? It's not because the technology is mature enough to handle this right now. My software architect, my guru, would you agree? Oh, yeah, in my eyes, you're a guru. But of course, we have some other motivational forces. We are a technology company, but we're also thinking about how can we contribute on the UN sustainability goals with what we develop in Kongsberg. And within maritime autonomous surface ships, we actually contribute on 9 out of 17 of the goals. Some of them are obvious, but we also contribute on number 8, decent work and economic growth. And let me just tell you right now, autonomous ships is not the same as unmanned ships, just to make that distinction right away. For Yara Birkeland, it will be unmanned. Decent jobs. You think, how will people think about this? How will they react? But we still need the sailors. But they will not be sitting on the vessel anymore for unmanned ships. But we still need them on shore. On the shore control center, we still need that kind of competency. For vessels going long distance, for example, there is no point taking the crew off the ship because there is so much maintenance going on, but they can have more tasks, they can have more decision support to have safer navigation, for example, to be able to concentrate more on the maintenance tasks. When it comes to goal number 11, sustainable cities and communities, this is perhaps where autonomous vessels together with low emission or zero emission solutions will reach their full potential. If we're able to reduce the emissions and reduce the need for infrastructure on land, that is really the way to go forward. Because if we look at the large cities, for example, how many of you have tried to drive into one of the larger cities in Europe during rush hour? It's terrible. You're stuck in hours in traffic for hours. Even some of our largest logistical movers, they say that the average speed for their trucks is 5 kilometers per hour. That's not fun. Think about having that kind of a job. It's not fun. And the next generation growing up now, they are not interested in spending so many hours on the road doing absolutely nothing. So this is a real potential. If you look at Japan, for example, there is no more space on land. They're actually building highways on top of each other. At the same time, the largest companies there, they already have a quayside. So we have a lot of potential moving goods from the roads to the water. Number 17, partnership for the goals. This is the most important one for us right now. There is no legislation in place for unmanned vessels per now. So from day one, we invited in the Norwegian Coastal Administration and the Maritime Association to work together, and we're actually forming the legislation for future autonomous surface ships. And what we do in Norway right now will also have implications on the work that the IMO is working on right now. So we are actually a driving force setting the standard in Norway right now. That's awesome. So, okay, we have the motivation, but why us? Why did Yara come to Kongsberg? Well, it's because of our history. If we start at the top, for example, we have a 200-year-old history. I'm not going to draw the lines all the way back then, but at least 272 here with the data chief with Kongsberg Nordkontroll. The first installation of an unmanned engine control room, for example, that was a huge step in the shipping industry. Being able to reduce the shift on the vessel from 12 to 8 hours, for example, freeing up a lot of time for people just sitting and observing instrumentation. Now tasks were automated. 17th of May 1977, we had the first installation of the dynamic positioning, and it was successful. It's not an autonomous system, but it's at least an automatic system. The operator tells the system what to do, and the system performs it, while the operator just monitors. Together with the Norwegian Defence Research Institute, FFI, we have been working together with them since 1991, developing the autonomy brain for AUVs, autonomous underwater vehicles. And that AI core, which we have been refining since then, forms the basis for the AI core for autonomous ships on the surface. I'm just gonna let the next video speak for itself when it comes to remote operations and the benefits you can have from that. Oops. As you can probably imagine, it's very nice for the crew to be able to sit 6 kilometers away and watch this go the wrong way. So safety in remote control is an essential issue. I will get back to this. Just to complete it, Odin is a high-speed water jet-powered surface vessel. And at 30 knots, it's able to detect targets and reroute its mission to be able to avoid collision with using sensors and putting them together to have an augmented reality picture around it, situational awareness. And we're also testing autonomous sensor fusion for lifeboats, actually, up in Trondheim, you can say. The autonomous test area, which is indicated at the bottom here, is actually the world's first, and it's in Trondheim. And now we have one in Horten, and there are more to come. So Norway is really taking steps towards allowing autonomous vessels and development of that. And just a fun fact, the area we're talking about is not closed off for leisure crafts or kayakers or swimmers or ferries or anything. So when we are testing our equipment, we need to interact with the physical environment. So that is a really good test arena for us. At the bottom, we have the sea kit, which is actually just a suitcase for an AUV, and it's able to be traveling for 100 days without any contact with the mother vessel. So it's fully autonomous. Yara Birkeland will not be fully autonomous because it has cargo, and the cargo owner would like that cargo to arrive at the predefined destination and not for the vessel to calculate the price for the cargo, for example, and expect to get more paid another place. So that's why it's not fully autonomous. Okay, so why now? We all know that we are in a shift right now. The manufacturing industry has seen 4 major industrial revolutions and advancements throughout centuries. We are building on, first we automate dull, dirty, and dangerous tasks. We put them together in systems. And now we're actually going a little bit further than that, collecting data, putting things together, giving you a new reality, being able to test out before you actually have a physical thing. And that's what's enabling this system we are talking about now. It's a timing, which is good for this right now. And in addition to that, there are central factors which we can benefit from with the maritime autonomous surface ships. So time is helping us. If you look at this, for example, simulation. How many of you think that the first test ever will be performed without people on board and classification societies being happy with that? Of course, we need to have simulations. We need to compute this. We need to test it in all sorts of different scenarios to be able to demonstrate the safety of the solution. So what does this mean for autonomous ships? We also have other influencing factors. You can guess what this is. For Kongsberg, for example, the maritime sector has been heavily invested in the oil side. So when that went down, there was suddenly room for people to be able to do other things, to look to new markets. We had a motivation to look to new markets. The Paris Agreement, with emission reduction all over the world, is helping us, driving this potential forwards right now. It's very good. It's a good timing. IMO is helping us. Focus on the environment in the shipping industry. even large companies are changing their names to accommodate for that shift, which is actually happening right now. And I have a quote from the CEO of Yara. He said that those companies that understand that there's money and business in the UN sustainability goals, they will be here in the future. Because there is actually a lot of money in this. EU is having a lot of funding projects, external funded projects, to look into environmental sustainability solutions, eco-friendly, green solutions for the maritime industry. And of course, we are benefiting from that also. But now we've talked about why the timing is right, why we think we have the competence and everything. But what is actually the solution? Because autonomy, that's not the end goal. That is just an enabler to get something more. Okay, so let's have a look at what we put into the concept of maritime autonomous surface ships. So, what is autonomy? The extent to which a system can carry out its own process means it's not a question of everything or just something. You know, we can have parts of it. Hence, my reference to autonomy and unmanned. Those are two different things. You can have several levels of autonomy without it being unmanned. Different instances are trying to put words on this. If we look at the AMO Center at NTNU, for example, they have 3 different levels of different degrees of automations. And also the Norwegian Forum for Autonomous Ships have tried to classify how different manning levels and different automation levels go together. And if you look at that matrix, the Yara Birkeland is on the right-hand side, on the constrained autonomous side, meaning that there are people in the loop still. It is not totally decoupled from people, but they will now be sitting on the shore side, and I'll get into that. Development areas and products for us. Of course, we are developing a lot of new technology in-house, which is a benefit for us. The green areas here are the dynamic positioning, for example. They are things that we feel pretty confident about. We have full control of this. We've done it before. It's nothing new to us. But we are taking the people away from the ship. So the ship needs to be able to identify its surroundings. We introduce situational awareness. We are looking at perception, cognition, action. Advanced maneuvering, autonomous navigation is a central part of it. We have here, for example, the guidance system, collision avoidance, following call regs. It's really important that Yara Birkeland behaves like it should and like it's expected by other seafarers. Otherwise, we will have problems. We had a film crew from Danmarks Radio shooting a documentary on automated ships and other instances of automation. And after they've been together with us for a whole day, the reporter said, I think it's kind of scary. You know, it's no people on board. How will I know that? But at least it has a friendly color. It's blue. So, you know, the human aspect of it is really important as well. But from a technological standpoint, we are firstly looking to solve the challenge and then the human aspect of it. But people have different ways of looking into it. But as I say, it needs to behave like a regular ship. It's really important. Engine control room and machinery. This is a fully electrical solution, and the battery capacity for Yara Birkeland is 7 megawatt hours. So it's actually the largest battery installment on any maritime vessel right now, meaning that it's a huge responsibility for us for the condition monitoring and control and expanding the life cycle management of that battery package. But at the same time, not so many moving parts, making it easier for us. Communication to shore and the shore control centers, of course, are also very important aspects. But I will get into that more in detail. But from a very keen eye, looking at this picture, I know it's a lot to take in. But in Kongsberg, we are actually able to shop around for the best products and technology solutions to get a best possible solution as a whole system. But you can imagine that one key word in this picture is configuration management. Who's going to have that job? Not me, but someone will need to take care of that. Situational awareness. Using sensors, putting them together, correlating the sensors to get a good understanding of what's happening around you. What if the captain is able to actually get that view which is best suited to his needs? Have you ever played PlayStation, for example? Sitting in a car, you're driving a car, you're competing towards your friends. You will probably not select the view where you're sitting inside the car, right? You would like to see further ahead, and you'd like to see around you what's going on. And this instance is just 12 cameras, regular cameras, store-bought, put together on Hurtigruten, and just using algorithms to sew it together, just to get a nice view of what's happening. And it's actually also detecting targets and training its models to learn and detect and recognize targets. And that will be used to have safe distances from different targets and also categorizing them. And this is not really advanced. It's quite easy to do. But of course, having a solution which is verified with the regulatory bodies, that's another issue. Just going to go a little short about other aspects. We're working together with other companies on a stepwards approach toward the full picture, which is Yara Birkeland. Bastefosen, anyone traveled on that one before? Hortenmoss? Yes! If you go on number 6 next year, it'll dock by itself. Of course, there will always be people on board because it's not a mission for them to take away the crew, but they want to increase the decision support and the safety and the consistency of their operation. But we will be doing the docking operation. Remote operation, as you saw in the video before, you can imagine also for firefighting vessels. It would be nice to be at a safe distance and put out fires. And also you can imagine that one operator is able to control several vessels to fight the fires at the best practical way. And this design, together with Robert Allen in Canada, it looks like something my kids would watch in Fireman Sam, for example, but it's still functioning, and people can climb onto it from the water. So it's a nice and really adept little vessel. Asko, traveling on the roads, moving a lot of goods, traveling through Oslofjordtunnelen every day. People who use that route is a tunnel, a subsea tunnel. It's closed almost 300 times a year. You can imagine that interferes with their logistical operation. So now they are looking together with us to make autonomous barges crossing the Oslo Fjord, fully electrical also. So we're taking steps towards autonomy. And the X-Prize, which I talked about, which is fully autonomous. It's hard to talk about maritime autonomous surface ships without going into safety. Cybersecurity is a hot issue here, and that would be a lecture by itself. But what I can say is that we're building on safety levels down to component level, and lucky for us, we have that ability and knowledge from our defense area in Kongsberg. And we're taking that kind of knowledge into how we build this system. Collision avoidance, together with colleagues, sensor fusion, and situational awareness, are the primary functions necessary to be able to fulfill autonomous surface ships within the regulatory framework. And sensor fusion, of course. We talked about that. It's nothing more than what people are doing. We use our senses, put them together in our brain, and we get a good perception of our surroundings, how we should behave. But I'm guessing some of you are sitting here thinking, one thing is to get the system to react to something it has identified, a situation it has identified. But what about the captain, the knowledge it has? He probably would take action if he senses that something is about to happen before it can actually see something in the water or something happening. How will we be able to train that into our systems? We don't know yet, but we're going to figure it out. Digitalization, that's a part of it. We have a twin. We have a twin, and we're building it down to the rotating components of Yara to be able to plan the voyage and to perform voyages in all kind of weather conditions and situation, cutting out engines and stuff, to see how the vessel performs and to be able to make it as safe or safer as conventional shipping today. Conditioning, monitoring of everything on board. You need to have a full picture of what's going on when you're actually sitting on land instead of on the vessel, and the deep learning to actually train your algorithms. We will have a period with people on board, and we're able to learn a lot from that operation before it will be fully unmanned. But that was the vessel by itself. So what's next? We talked a lot about what different kinds of vessels. But what's next? Is that all? I don't think so. If you look up at the far right corner, you can see a sketch from Bård Eker Design, connecting everything together. In Trondheim right now, they're working on a little bicycle ferry to 12 people, and it's on demand. If you need the ferry to come over, you just push an app, and it will come and pick you up, instead of having regular scheduled hours. Of course, it only takes like 5 minutes across over Ravnkloa, but still, it's a really nice approach to it, getting things connected together and on demand. The operational part of it, the shore control center, is a really fundamental part of autonomous surface ships. And it's not just taking the crew from the ship onto the shore. It's a lot more than that. It's actually building on more. But what we at least know we need to cover is the onshore systems. We need to have that, the ship systems to have full control of that, and the real-time aspect to be able to take remote control over the vessel. As we can see here, there's a lot of planning. It's a logistical solution. As I said, Yara Birkeland, they have a logistical challenge. It's not just a vessel, it's a part of a logistical chain. And we need to be able to interact with the factory, with the cranes on the quayside, with the sailing permittance from the Vessel Traffic Surveillance Center, all the way to we have delivered the goods on the other shore. We have the ship systems. We need to take care of maintenance. Everything going on board, we need to know the status on that. And as I said, we need to be able to take remote control when we have a situation requiring that. But what else? What are the actions actually the people on board are doing manually today? For example, I just talked to a captain. He said, I'm filling out a checklist 8 times a day manually. Why is it manually? Is it able to automate it? To have a historical view on it, for example, just small things. They don't need to be sexy or fancy or very high tech, but it's really helping the people. So those are the things we are looking into. More services than just being the captain on the ship, watching the ship. So the people on the shore center will have increased capability on what they're actually doing. Another thing we've done, I mentioned we were 200 years old, right? Feels like we're a little startup in a large company. And we have also taken new steps. We have teamed up together with Wilhelmsen on establishing Masterly, which will actually be the operator of the world's first autonomous ship. So we, in Kongsberg, we will go in the technology, we will set up what they need with the hardware, with the systems and everything. Wilhelmsen will provide the knowledge of ship operation, and Masterly will actually take care of everything from design phase to manning up the people sitting in the shore control center, taking care of maintenance and the full operation. So that's interesting, I think. Right now, it's only one person working in that company, but there are more people to come, and we have a vision, because we know that if we hadn't done this, someone else would have beaten us to it. So I think we are actually taking some steps here. Just 2 years ago, our summer students set a world record by water skiing behind an autonomous vessel. And we have now gone into contract with Yara Birkeland, the world's first autonomous and fully electrical vessel. And we're also building up the world's first company for operating unmanned vessels. So I think it's kind of cool. We have guts, even though we're 200 years old. Jan Eivind Wang at Wilhelmsen, he is a seasoned person with a lot of experience. He said, if I were to apply for a job in Wilhelmsen today, I wouldn't get it. Right now, they're actually hiring 30 people with IT background. They have traditionally been a shipping company, but they see that there's a shift in the competency needed for the next generation. Okay, there are a lot of challenges. We are not there yet. Rules and regulations, infrastructure, we talked about that. The technology, we're fairly sure will handle that one. Societal impact, how people around us will interact to this. How will they respond to it? Well, it's a development that is actually coming. There's no turning back, but we need to consider the people here, and it will be a stepwise approach. There are a lot of challenges, but that's the fun part. There are also a lot of possibilities. And the timing is right now, and we're here to do it. So, thanks.